Example 1, adding fractions algebraically. And what I'm looking at is a factorable denominator. So as soon as I see on the denominator x to the second power, I'm looking at a possible factoring situation. Okay, factor trinomial, lesson 69 of the book, we did that. We're in lesson 101, so we had 32 lessons to practice this skill, hopefully getting pretty good at it by now. This fraction here, 6x on top, can be broken apart into the two numbers, -4 and 3 would make the -12 product, the -1 sum, right?
Mm-hmm.
Yeah.
So the factored form of x squared minus x minus 12 is
X minus 4.
and x plus 3. Priority 1, factor everything that's factorable in these problems. That allows you to better determine the least common denominator. The second fraction is, as it already is, -p on top over x minus 4 on the bottom. And what's going to happen in every single problem in this section is that once you factor the thing that's factorable, the factors will match some of the factors. So you already have part of the common denominator existing in these problems. Every single problem is going to be like that. Okay? I then need a common denominator, so I can compare and say what's in this fraction that's missing in this fraction. Obviously it's x plus 3 in the denominator. So this has an x plus 3, this doesn't. I need to put an x plus 3 on here, which requires me to put an x plus 3 on top. Alright. Now let me caution you about one quick thing here, because this happens a lot. And people mess up on it even more. Probably not even more, but almost as much. How about that? Occasionally people don't mess up with it, almost everybody else does, so most of the time people mess up on it. So be careful. There's a minus in front of this fraction. That minus sign is attached to the first object here that's being distributed through this parentheses. And I do expect the top to be completely simplified. The bottom can stay factored. I don't care about the bottom. But the top I want it to get completely simplified. So 6x is only 6x because I didn't do anything to this fraction. Right? I factored the denominator to create a factored form of the denominator so I could compare them. Right? But this denominator already has everything it needs to have. I didn't have to change it whatsoever, so that first fraction stayed as is. The second fraction, I had to multiply top and bottom by x plus 3, a binomial that's being multiplied by the current numerator, which is -p. -p times x makes -px, and -p times 3 makes -3p. That minus sign right there, a lot of people miss. Because instead of seeing minus this, they see px, which they'll put a minus because there was a minus, and they'll just say plus 3p because there's a plus sign there. But again, that minus sign is attached to this. It's being multiplied through. Negative times positive makes it negative. So be careful of that. The denominator is going to be what the common denominator is, which is x minus 4 times x plus 3. The final step in these problems, if possible, combine like terms on top. Do I have any like terms on top?
Nope.
Nope. So I'm done. That's the whole problem. That's the easiest way to do it, and that's the way I expect it to be done every time. Factor, compare, common factor's already there, get the missing piece on the one that doesn't have the missing piece, multiply top and bottom by the same thing to make it happen, simplify as much as possible on top, leave the bottom factored.